straight lines revision. So in this video, I'm going to run through the key ideas that were developed during this topic, the key skills that you learnt. I'm going to give a few bits of advice and I'm going to finish up with some examples. And just to note, what this video is not intended to do is replace your notes that you already have on this, which are going to be more detailed. This is more just a quick reminder. Equations of straight lines. So there are three main kinds that you need to be thinking about. And it makes sense to start with the first one, which was introduced during that 5. And that is y equals mx plus c. And you're going to want to use y equals mx plus c when you know what the gradient is and you can see what the y-intercept is, in this case of -4. Sometimes you might not see a sketch, but instead you might see written down that the graph goes through the point 0, -4. Well, we'll have a think about where 0, -4 is. Any coordinate that starts with 0, it's the y-intercept that you're being given. So in both those cases, we've got m is 2 and we've got c is -4. So we can just put those in. Okay, we're not always going to be so lucky. Quite often we're not going to know the y-intercept. Instead we'll have some other points here. Well, that's fine, we can still make an equation out of that. We do still need to know the gradient. In fact, we'll always need to know the gradient to write the equation of a straight line. So we've got m there is -2/3, and we've got a point here, -4, 3, and the equation we're going to use is y minus b equals m x minus a. So there we've got m, and a and b refer to this point here. That's the coordinate AB, and any coordinate will do here. So we're going to put those in, and as we do that, we're going to take away 3. We're going to put -2/3 in here. As we do this, we're going to watch out for taking away a, we're going to watch out for double negatives. So taking away a is going to be taking away -4, well that's just the same as adding 4. Now, it used to be that that was perfectly acceptable as a final solution. However, the marking schemes are now leaning towards rearranging this into one of two forms. Well, one thing is you could multiply this out here, get everything to one side apart from the y and change it into this form. The other option is the third type of equation, which isn't used to make an equation, it's more what we could rearrange it into, and that's the general form. And what that involves is getting the x and y terms on one side and a number on the other. And that's mainly used, if you think back to your National 5, simultaneous equations when you want your x and your y's lined up and your number here. Well, we do that in higher as well. Okay, so to write the third type, the general equation of a straight line, I'm actually just going to take this one here. I'm going to do a few things to it and that will form the third type. So let's take where we've got to so far. Now, I wanted to throw one in here which has a fraction here because that makes it slightly trickier. Now, we could just multiply out by -2/3 and deal with the fraction afterwards. That's perfectly okay. Or we can actually deal with this now. The thing that's not nice about this is the fraction. So if we can get rid of this 3, it will be much nicer. So what I'm going to do is I'm going to times everything by 3. So if I times y by 3, I get 3y. If I times -3 by 3, I get -9. And what happens when I multiply this whole thing by -3 is the -3 cancels, and I'm left with -2x plus 4. And now I can start to multiply out. I could have multiplied out first, but I usually prefer to do it at that point. So we get 3y minus 9 equals -2x minus 8. I'm going to bring the x and y to the left, and that'll give me 2x plus 3y equals, so I've got -8, I'm bringing -9 across, so that's going to become +9, so I'm going to get -8 plus 9 is 1, and that is the third form. It doesn't really matter if your x comes first or your y. Most mathematicians like to put the x first, but it doesn't matter too much. Okay, so that's nicely set up for any simultaneous equation, point of intersection work we may want to do. The gradient of a line, or how steep it is. So let's start off by talking about parallel and perpendicular. So parallel is nice and easy. If two lines are parallel, then they have the exact same gradient. So this line here, if we think about y equals mx plus c, this line has a gradient of 5. So if I ask you to find the equation of a new line, which is parallel to this one, but passes through these points here, well, we're going to have the same gradient. So we're also going to have m equals 5. And we're going to use these points, a and b, and we're going to use the form y minus b equals m x minus a. And as always in this topic, look out for negatives, double negatives, and so on. So we're going to have y minus 4 equals 5. X minus minus 1, well, that's just plus 1. And as I mentioned just a moment ago, the SQA is liking us now to actually multiply these out rather than leaving them like this. So no fraction here this time. Y minus 4 equals 5x plus 5. And we can either take it across and make it a general equation, in other words, y and x on one side, number on the other, or we can write it y equals, you decide what you would prefer here. Okay, so that's parallel. Now let's switch to perpendicular. So perpendicular gradients, we're going to flip them upside down and flip the sign as well. In other words, let's start with 4 over 3. The perpendicular gradient to 4 over 3 is minus 3 over 4. So we've made it a negative and we've flipped this fraction upside down. So if we had a gradient of minus 1 over 7, well, then the perpendicular would be positive 7 over 1, which is actually just the same as 7. So what do we do if we have the gradient, for example, of 5 and you want to invert it? Well, one way of thinking about it is making 5 into 5 over 1. So the perpendicular gradient is going to be negative 1 over 5. And the same trick will work for finding perpendicular gradient to minus 1. However, it might be easy just to remember that the perpendicular to minus 1 is 1, okay? So all of these are perpendicular to each other. Okay, so let's use that now. First thing to note is with this example here, we can't actually clearly see what the gradient is. The gradient isn't simply 2. We can only say that when it's rearranged y equals. So the first thing we're going to need to do here is rearrange this. So what I didn't say was what we're looking to do is find the equation of a line perpendicular to this one, okay, in other words at 90 degrees to it, going through these points here. So we can take these as the points A, B, and we can now take the gradient. Well, the gradient of the line here is minus 2 over 3, and the gradient perpendicular to that, I often write m perp, okay, but you may have been shown a different way to write that. The perpendicular to this is going to be positive 3 over 2. And now I'm going to use y minus b equals m x minus a. So y plus 1 equals 3 over 2 x minus 2. Now what I'd like to have a go at now is, if you saw the previous example, I'd like to have a go at multiplying this out and seeing if you can get this into either this form, or actually sometimes when there's a fraction, but I quite like to go with the general equation, and that's what I'm going to do here. So have a go at that. I'm just going to write down the answer here. Okay, and it's perfectly okay to have written minus 3x plus 2y, that's also okay. You might even actually have 3x minus 2y equals 8, that's also the same. One thing that I would say about perpendicular lines is, what about if we have to show that two lines are perpendicular? So let's say we're asked to show that 4 over 5 and minus 10 over 8 are perpendicular. So one thing we could do is we could simplify this, and we could try and explain that when you take this one and you flip it upside down and you make it negative, it's the same as this one when you simplify it, and so on. But there's actually probably a nicer way to do that. Perpendicular lines, two perpendicular gradients will always follow the rule that when you multiply them together, you get -1. So if you're asked to show the two gradients perpendicular, often you're better just to multiply them together, get the answer -1, and make a statement. So in this case, 4/5 times by -10/8, well, that's going to be top times top, bottom times bottom, gives us -40/40, which is the same as -1. And then we would say m1 times m2 equals -1, therefore perpendicular. Continuing with gradients, one of the most used things in this topic is the gradient formula, which says that we can find the gradient using y2 take away y1 divided by x2 take away x1. So if we have two coordinates and we want to find the gradient of a line between them, then we can use this. Now, it doesn't matter which coordinate you decide is coordinate 1 and 2. You can make it whichever way around you want. I'm going to make this one coordinate 1, so that's x1, y1, and I'm going to make this coordinate 2. So that's going to be x2, y2. So we're going to be very careful with negatives here. We're going to put -3, y2, take away y1, and we're going to divide by x2, take away x1. So take away -3, well, that's adding 3. So what we get is -10/5, which is the same as a gradient of -2. Okay, a couple of things to watch out for there. If you ever get a gradient of 0, then when you're looking at is a flat line. And a flat line, instead of using y equals mx plus c or anything like that, a flat line, we're going to write using the equation y equals. So in other words, if you have a flat line and it goes through the point, let's say 2, 7, then the y coordinate for all of these points is going to be 7, so it's got the equation y equals 7. And if you ever put in values for your gradient formula and you get a divide by 0, so for example -2 divided by 0, then we say that that's an undefined gradient. And an undefined gradient is a vertical line. And we would write that, so for example, a vertical line going through 4, -1. Well, a vertical line will always go through the same x coordinates at all points. So the equation of this line, instead of using y equals mx plus c, would be x equals 4. And a good way to remember those is it's like the opposite of what you as the axes. So a horizontal line, well, that's the x-axis, but the equation is actually going to be y equals. And a vertical line, well, that's like the y-axis, but the equation is going to be x equals, so it flips compared to the axes. So moving on from that is this m equals tan theta here, which tends to cause quite a few problems. So let's look at a basic example first of all. If a question ever starts talking about the gradient and the angle that a straight line makes with the axis, m equals tan theta is pretty much certain to be involved there. Okay, so if you know what the angle a line makes with the x-axis, and it's always got to be, if here's the x-axis, it's always got to be a counterclockwise direction, so opening up from there to there. If you know that, then you can find m. Whether it's a calculator or non-calculator, we're just going to put it in there. So m equals tan 45. Okay, and thinking of those exact values, we could make a triangle, or we could put it in a calculator if it was in a paper 2. We would get the answer that the gradient is 1. Okay, so what about this one here? Well, this time I want to do the opposite. If I know the angle, I can work out the gradient. If I know the gradient, I can actually also work out the angle. So if I was to give you a gradient of m equals 1 over root 3, and I was to say work out this angle here, well, first thing you should be thinking is, hang on a second, I can't work out this angle here. My m equals tan theta is going to help me work out the angle it makes with the x-axis opening up anti-clockwise. So it's going to find me the angle here. Okay, that is what m equals tan theta is going to give you. But if we get that, we can use some geometry to work out this one here. So let's start with m equals tan theta. If you use m equals tan a, that's exactly the same thing. So I'm going to put 1 over root 3 in place of m. I'm going to solve it. I don't actually need to use cast for this. So I'm going to swap these round, and then I'm going to do an inverse tan. And I get the answer that the angle is 30 degrees. However, just bear in mind that what I've worked out is this one here. So I'm going to need to do an extra step to work this out here. Well, here I've got a right angle. Here I've got 30 degrees. So far I've got 30 plus 90. I've got 120 degrees. And the degrees in a triangle total 180 degrees. So this missing one must be 60 degrees. Okay, now, one note on this is, especially if you're using a calculator, if you get a negative answer at this point here, okay, you don't need to use cast. You can do an inverse tan of negative, that's fine. But if you get a negative answer here, all you need to do is add 180 degrees and that'll work every time. So for example, if you get an answer of minus 50 here, you don't want to write down minus 50 as the angle. You want to add on 180, so the actual answer is 150. Okay, so now two important formulae. First of all, the midpoint. So this is about finding the middle of 2 points, or in other words, the middle of a line is how it's quite often used. So there's a formula here. Basically what it's saying to do is add together your x-coordinates of each point, divide it by 2, okay, the average x-coordinate, and add together your 2 y-coordinates and divide it by 2. Don't forget to divide by 2, it does happen quite often, so let's give that a go here. So I've got a and b and I want to find the midpoints. Perhaps there's a line AB and I want to find the midpoint of a line. So I'm going to add together 4 and 6, and I'm going to divide by 2 in a moment, and I'm going to add together minus 2 and minus 8. They're going to go together, divide by 2, so that's going to give me 10 over 2. That's going to give me minus 10 over 2, and the midpoint here is 5 minus 5. Okay, so what about the distance formula? Well, that's to find the distance between the 2 points, or if AB was a line, it would be used to find the length of a line. So what it's basically saying here is find the difference between the x-coordinates and square it, find the difference between the y-coordinates and square it, and square root it. And it looks very much like a Pythagoras equation here. In fact, if you were to have a look at your notes, where there's probably one of these done using coordinates, you'll see that that's basically what it is, it's Pythagoras. So I'm going to, now you can choose which one you want to take away first. It really doesn't matter too much. So I'm going to do 4 take away 6 squared plus, so if I've done 4 take away 6, then I need to do minus 2 take away minus 8, which is minus 2 plus 8. The main thing you don't want to do, and you don't want to do this with the gradient formula either, is you don't want to start saying I'm going to do this take away this, and then do this take away this. So if you started here take away here, for gradient formula, you would want to go here take away here on the for the x-coordinates. Okay. So that's going to give me minus 2. When I square that, it gives me 4. That's going to give me 6, and when I square it, it's 36. And I'm still to square root these. And that'll give me the square root of 40. Now, depending on what kind of exam it is, if it's a calculator exam, it may be looking for you to write it as a distance and put it in your calculator to get it as a decimal. Or it may want to keep it as an exact value. Sometimes what you need to do, and the question should tell you if this is what it expects you to do, but sometimes what it'll want you to do is to simplify the surd. So if you remember from Nat 5, the way we're going to simplify that is we're going to think of our square factors of 40. So factors of 40, so we've got 2, 8, 4, 10, 20. our square factor in there is 4. So we write root 40 as root 4 root 10. 4 times 10 is 40. And then we say, well, that root 4 is just the same as 2. So this becomes 2 root 10. Okay, so if it did ask you to simplify it as far as possible, then that would be what you're expected to do. Collinearity. So collinearity is when 3 or more points lie on the same straight line. So take points A, B and C. Well, I've drawn a wee sketch here and I've made my sketch deliberately a little bit unclear. If this was a single straight line, then I'm showing that they are collinear. However, is there a slight bend here? Well, if there was a bend, if the straight line between A and B is a slightly different direction from the line between B and C, well then they're no longer in a single straight line. And that's how we investigate whether points are collinear. We find the gradient between 2 of the points, then we find the gradient between one of the points and a third point, and we see if that's the same. So I typically go with, if I'm given A, B and C, I typically begin by finding the gradient from A to B, the first section of line. I don't need a sketch, but that's what I'm thinking. So I'm going to use y2 take away y1 over x2 take away x1. And it is. So it's going to be a straight line, but how do I explain that? Well, I need to state a couple of things. First of all, I need to say that gradient from A to B is equal from the gradient to the gradient from B to C. So they are parallel, in other words. Now, if I have 2 lines with the same gradient, what's to stop them being parallel and never meeting? Well, they're going to be collinear if they are parallel and they go at some point through the same point. And we can see that the line from A to B and the line from B to C, they both pass through B, so we're going to need to say that. The gradients are equal, so they're parallel, and they share a common point, B. Therefore, they are collinear. Okay, so there are 3 main constructions that we make in the straight line topic. The first of the 3 is perpendicular bisector. Now I've drawn a triangle here, ABC. I'm going to find the perpendicular bisector of AB. Now, when we make this, actually, you don't need a triangle for perpendicular bisector. It's actually going to have nothing to do with C. It's only going to have everything to do with the line AB. So the perpendicular bisector AB, bisector is going to cut it in 2. So it's going to go through the middle of AB and it's going to meet it at 90 degrees. So that's the perpendicular bisector of AB. So first thing I'm going to need to do is find the midpoint, the middle of the line AB. So there we go, I've got my midpoint here, and that is a point that the line is going to go through. So I'm actually going to label that A and B just now, because I'm going to use that when I come to write the equation. So I've got A and B, I've got the point it goes through, and now need the gradient of it. What do I know about the gradient? Well, it's 90 degrees to AB. So I'm going to start by finding the gradient of AB. Okay, so I've got my gradient of a line AB, but I'm going to be careful not just to write M here, because that's not the gradient I want. I want the perpendicular to that. So if you remember from before, we flip it and change the sign. So the perpendicular gradient of 3 is going to be negative, And if we think about how to do that, imagine writing 3 as 3 over 1 and flipping it upside down, so we're going to get negative a third. And now we're going to use y minus b equals mx minus a. Y minus. And remember that when we see this, we now want to simplify it. So it's got a fraction, so I'm not actually going to multiply it yet. First thing I'm going to do is multiply it by 3. And now I can multiply out, and I can write it either as the general equation, or I can rearrange it to y equals. As I said before, whenever there's a fraction, it tends to be easiest to put the x's and y's on the left. Okay, so the next construction we're going to do is the median, and the median does need to involve a triangle. So the median goes from one corner of a triangle to the midpoint on the opposite side, and usually it doesn't meet at a right angle. So I'm going to ask to find the median QS, the median through QS. And the first thing you'll be thinking is, well, where is the point S? It doesn't really matter. What you should be focusing on is the median from Q. Okay, so that's going to go from Q to the middle of the opposite side, which is about here. And this is the line that we need to find. And what's probably happened here is that the point S, the midpoint, it's been called S, and we're asking for median QS before we can even see the point there. So really just focusing on the median and whichever of the 3 sides is named in this place, in this example, Q. So what I'm going to need to do is, well, I already have an A and B point, should I choose to use it, and I'll explain that later. But what I don't have is a gradient. Now to find the gradient, I'm going to need, with a median, to find the midpoint first, and then I'm going to use my 2 points that it goes through and the gradient formula. So I'm going to start by finding the midpoint of PRS. And there we go, that's S, or the midpoint of PR, that it also goes through. And what I said about if you choose, you've actually now got 2 different points it goes through. So when it comes to writing your equation, you can choose make this A and B, or make this C and B. It may look slightly different, but what you actually have is the same equation. So what we now need is the gradient from Q to S. Okay, and now we can write y minus b equals mx minus a. And what you'll notice there is quite a lot of points there. I was thinking to myself double negative. So when I did the gradient here, I was doing 1, take away minus 1. 1 plus 1. 5, take away minus 1. 5 plus 1. And when I was putting these points in, I was thinking y minus minus 1. X minus minus 1. Again, I don't want to leave it like this. I'm going to rearrange it, and because there's a fraction here, I'm going to actually write it with x's and y's on one side and the number on the other. I'm going to start by multiplying by 3. Okay, there we go, median QS. Okay, and the final of the 3 main constructions that you're going to see is the altitude. Now, the way to remember altitude for me is to imagine a mountain and imagine someone looking up at the height of it. Now, when you measure the height of a mountain, okay, the altitude, you don't take a sloping angle, you look straight up to the peak. So the height of this mountain is the distance from a base up to a peak there. Kind of looking straight up 90 degrees. So it goes to a corner of a triangle and it meets the opposite side at 90 degrees. Now, if I can picture that, then when I need to find any other altitude, I'm just going to bear that in mind. So in this case, I want to find the altitude passing through M. So what does that look like? Well, it goes from M and it meets here at 90 degrees. There's absolutely no requirement that that should be the midpoint, so we're not going to think about midpoint at all. Okay, so what do I know? Well, I know a point that it goes through. I know that it goes through this point here. So I've got my A and B value already. And what I need is the gradient. Now, what do I know about the gradient? Well, it goes at 90 degrees to ln. So I'm going to start by finding the gradient of ln. And once I've got that, I'm going to write down the perpendicular gradient to ln. And then I'm going to put that together with this, and I'm going to do it all in one go just now. And then we'll go for altitude through M. Okay, so we're now going to do a couple of examples. Okay, let me show you the first one. So this is from 2013, paper 1, question 5. We're just going to do a few examples, and if you find attached to this video a bunch of further past paper examples for you to try, which give you a chance to try all of the different things we've talked about in this video. So question 5 says, the line L passes through the point minus 2, 1. Well, I'm going to want to write that down. Okay, it passes through minus 2, 1. And what I'm thinking at this stage is, I'm thinking that, well, that's like my A and B value. I'll take those. And it is parallel to the line with equation 5x plus 3y minus 6 equals 0. Okay, so it's parallel to this line. So what that tells me is it's got the same gradient as this line does. But what I don't know at the moment is what the gradient of this line is. And I'll need to rearrange it into a y equals form to answer that. So let's do that now. Okay, so there we go. So the gradient of this line then is minus 5 over 3. So I'm going to take my gradient, my A and B values, and I'm going to put that into y minus b equals m x minus a. And I'm going to multiply this out, okay? So I'm going to times by the 3 here. Seems to have always been 3s that we've seen today. That's just pure coincidence. Could be any number down here. And we just times by whatever number that was. So if it was 7, we would be timesing by 7 here, okay? Okay, there we go. So you won't see multiple choice questions in your prelim or your final exam, but it's a good chance if you are practicing with these to check. So I've got 3y plus 5x equals minus 13. Okay, now that ties up with D. Okay, so my next example is again a past paper question, 2014, paper 2. Question 1, have a look at it just now. Okay, so we're going to start by obtaining the perpendicular bisector. So I need to be remembering that perpendicular bisector cuts through the middle of AB and it's going to go at 90 degrees. So let's start by finding that midpoint of AB. Okay, next, well that's my A and B values, so I'm going to make a wee note of those. Now I need to find the gradient of this line. So it's perpendicular to AB, so I'm going to find the gradient of AB, and then I'm going to write down the perpendicular to that. Okay, so my gradient is 1 of AB, and I need the perpendicular to that. So I can either think of 1 as 1 over 1 and flip it upside down, and I'll get minus 1 over 1, which is minus 1. It's often easier just to try and remember that the inverse, the perpendicular to 1, is minus 1. Okay, so now I'm going to write down the equation. Okay, and that is part A done. Okay, so that's part A done. So let's now have a look at part B. So the median from A has equation y plus 2x equals 6. And we're asked to find T, which is the point of intersection of this median and the perpendicular bisector of AB. Well, we found the perpendicular bisector of AB, it had this equation, and I've jotted that down from part A. So what we're wanting to do is find the point of intersection of this median and this perpendicular bisector. So I'm going to just write this one underneath here. I'm going to line it up. And this is what we said about the general solution being a good way to write it because then it lines up quite nicely like this. So we're going to want to make some of these equal and opposite is a way to put it. So we can cancel. So I'm going to take these two equations and I'm going to leave this one as it is. And I'm going to take this one and I'm going to times it by -1. And the reason is this will then become -y, which will cancel with this. So when I add these together, they cancel out, leave me with 0. When these add together, that leaves me with a single x. And when these add together, that gives me 1. So I found my x coordinate or my x solution. I'm now going to substitute 1 back into any of these to find my y solution. So I'm going to put 1 back into here. Okay, so T has the coordinate 1, 4. That's part B done. Okay, so for part C, we're asked to find the angle that AT makes with the positive direction of the x-axis. Now, as soon as I see that, I know that I'm going to use m equals tan theta. Okay, angle makes with the positive direction of the x-axis. And if I want to calculate the angle, then what I'm going to need to know is what the gradient is, so I can put that in here. Now, one thing to do would be to take the coordinate of A and take the coordinate of t, which we found in part B, and work out the gradient. And that'll be fine, you'll get the gradient there. However, a slightly quicker way in this case is to look at the median from A. Now, the median from A actually goes through point T. So we already have the gradient from A to T, and that is, well, if we have y plus 2x equals 6 and rearrange that, you will get the answer -2. If you can see that, great. If not, just use A and T and you will get the gradient of -2. So m is -2. Okay, so we're going to put this in, and this is one of the rare instances when we're going to do an inverse tan and we do not need to do a cast diagram, and we can actually keep a negative there as well. So let's see what we get with a calculator. Okay, so I get -63.4 degrees, and as I mentioned before, if you ever get a minus answer, that's basically telling you what the angle is underneath, and we want to be going this way. So what to do is add 180 degrees to your answer, and the answer is 116.6 degrees.